So today we're going to be getting on with BreakRSA from TryHackMe. This one's going to be a little different because I'm going to aim to try and talk through most of this one. Cryptography, certainly the cryptography we need to do for this box is not the easiest. So hopefully this is going to work. We'll see how this goes, and well, we might as well crack on with it. We have a HTTP server running. Our IP address is this, so we're going to go straight to it. And we just have some kind of quote. We can run a simple Dirbuster scan against this. We'll just see what it comes up with. And it's probably worth getting this information for the bot. Great. We have a hidden directory called development, which when we open that will bring us here. We have a log and a public IDRSA file. Random selected prime numbers P and Q are very close to one another. So interestingly enough, what we can see from this page is that first off we're going to be logging in as the root user. And that we're going to be using Fermat's factorization method, which had already kind of been confirmed by the information that we have here. And the IDRSA pub key we've downloaded, so we can go ahead and copy that from our downloads folder. Copy that over here, open it up. Brilliant, nice and kind of straightforward for that, I guess. Now, one of the things that we need to figure out for the questions here is the length of the RSA key. We can do that quite easily just by using keygen with L and F followed by the file that we want, and it's 4096. So we can go and tick that off on our machine. Now, how can we extract N and E from this? Because that is what it mentioned somewhere. So yeah, we need to be able to extract E and N. So pretty simply, how do we extract N and E from RSA public? Do Python. Python is a nice and easy scripting language that we can use. Nice and simple. This looks like it would work, and as mentioned, PyCryptDome was also mentioned here, so that looks like it would be pretty good. Nice and simple, so we'll just load up Python 3 and then follow this line by line. Crypto.public key. There we go, beautiful. We're going to open our file, which is just idrsa.pub. Read it in. We want to be reading the file, so we use R for that. That is all we need there. Import it with what we have just done, so RSA import key f.read. Capital K, always useful. Find. We'll get there eventually. And then it's just as simple as printing 3.kn and then .e. And that's brilliant because we can then take the last 10 digits from here, which will give us the answer to another one of these questions. 2, 3. Anyway, that is fine. We can exit out there, and we'll come back to that later, just for answering key. Now we need to get P and Q. We need to calculate P and Q from this. The box gives us an implementation for how we can do this using GMPY2. multi-precision arithmetic, which is always going to be useful when we're doing this. Now, what is Fermat's factorization algorithm? Presumably, this is going to take us the same bit that the log file says. Ends in 808. Yeah, that seems alright. Right, okay. Let's do some more research on Fermat's factorization method. This is something I've never heard of before, so I'm slightly confused as well. Wikipedia, interesting source, but we'll take it. And we have some pseudocode here that we can try and implement. So, by having a brief look over this, let's assess the situation. We can calculate P and Q, and then we can take P and Q to calculate N. Then with P, Q, and N, we can then calculate D, which will then allow us to break RSA. But how? How do we go about doing that? Just have a look for generating private keys. Let's see what comes up. I'm honestly not too sure. Because we do have data, and maybe there is something here that we can use? Cool. Okay, brilliant. So this assumes that D was already calculated, which we may already have. Yes, because if we have NP and Q, then we can make D. Yes. Great. So we do have everything that we need to do, and we can construct private components apparently according to this code. We can either do it kind of in the command line like that, or we can make a script that's going to do everything. Probably making a script that does everything is going to be easier, so we are going to go ahead and do that. So I will be back when we do have a script that does that. So we finally finished our script, and we have had it running. So we'll just go through what it kind of does basically. So we have the Fermat factorization here. We have another function that will calculate the private key, and then we kind of run through how our function works. So we start off by importing the public key, retrieving N and E, and then factorizing for P and Q from the Fermat factorization function. Now with N, E, P, and Q, we can then calculate what D is. We then have the difference printed out, as that is one of the questions for TryHackMe. And then we have the key exported because we do have N, E, P, D, P, and Q at this point. Now we need N, E, and D to be able to calculate it. And then it should, hopefully, all work. So we're going to use this and then access the box with our IP address. I'm going to say yes. And there we go. We have the flag. The details kind of around how this cryptography works are, I don't fully understand it, but I understand it enough to kind of to use the script. We basically took the implementation we found on the Wikipedia page. Pull it up. We take this pseudocode and then we convert it into some actual code. Calculating the private key was, I believe, something that we had on the TryHackMe page. I've just got it up. I'm just trying to double check. I'm not entirely sure. That might have been another thing from Google. I think that's actually from... either way, it's enough to get this to work. We can calculate the private key, and then we can use the factorization pseudocode that we found to get this all to